Welcome to the Heavy Mechanical Engineering Project. We start with the truck tire. This is a giant Roton 1020 tire. The yellow painted steel rim is extremely striking and sturdy. The mechanic is wiping it down and gaining momentum to roll the wheel into position, preparing for an incredible custom build. Two truck wheels are set up parallel to each other. A tape measure is pulled out to accurately measure the rim's inner diameter. From the material area, he selects two round steel plates, which are solid, incredibly thick, and heavy. The tape measure is again used to check the diameter, to ensure the steel plates will perfectly fit inside the wheel rim. A marker is used to meticulously mark the positions of the lug nut holes from the rim onto the steel plate. Moving on to the drill press, a specialized hole saw cuts a perfect circle right in the center of the steel plate. The flying steel shavings show its extreme hardness. A large bolt is placed inside the newly cut hole. The TIG welding torch is immediately activated. The bright arc welding sparks fuse the nuts onto the steel. Long threaded rods are screwed in and fixed in a circle. This is the base for the custom hub system. Now it's time to select the mechanical components. Thick cylindrical steel tubes and large heavy-duty bearings, a wide-rimmed tractor chain sprocket, and motorcycle brake discs are also carefully chosen. Two brake discs are stacked on top of each other. The components that make up the custom drive shaft are already laid out. Flanges, steel pipes, and brake discs all require extremely strict mechanical assembly tolerances. Measuring the dimensions of the small flange, the goal is to concentricate the main shaft assembly before drilling the mounting holes. The flange is aligned onto the giant steel plate. Coaxial alignment at this stage determines how smoothly the vehicle will run. The drill press resumes operation. The twist drill bit goes through the thick steel layer. Coiled metal shavings continuously shoot out. The milled hole flange is slipped onto the bolts, preparing for the process of creating a solid central block. Using TIG welding to tack around the base of the bolts, the meticulousness in every weld helps it withstand high torque. This flange is paired with a steel bushing, then welded around the edges, and attached directly onto the large steel plate. The steady welding bead completely seals the gaps. The dual flange structure gradually emerges, showing absolute sturdiness. Continuing to weld the flange onto the cylindrical steel axle housing, the welding slag and molten metal fuse together. An angle grinder is immediately brought in. The grinding disc flattens the weld surface, removing all the metal burrs. The surface is now completely smooth. The roller bearings are aligned, lubricated, and placed into the mouth of the steel tube. The mechanic places a piece of hard wood over it and taps it with a hammer to seat the bearing deeply without scratching it. The steel edges firmly clamp the axle housing assembly onto the vise. The solid steel shaft, which has been threaded at both ends, is greased and pushed through. The core shaft slides smoothly through the bearings. Now it's time to assemble the drivetrain components. The core chain sprocket. The small flange is brought out for TIG welding again, fixing 4 heavy-duty bolts to serve as a base for the rear sprocket, placing the large sprocket onto the flange. Using a wrench to tighten the nuts, getting ready for the vehicle's drivetrain. The drive sprocket is now seated on the flange. The bolts are tightened with a wrench to lock the transmission in place. The entire sprocket assembly is inserted into the main shaft. A large lock nut tightly secures the drivetrain assembly. The pulling force and torque will transmit through here without slipping. Next is assembling the steel block onto the base. The hub assembly is taking shape. The flange nuts are tightened. The wheel's center is reinforced for maximum stability. Evenly tightening the entire ring of bolts on the flange. Flipping this incredibly heavy metal block upside down. The motorcycle brake disc is fitted onto the opposite end of the shaft. Tightening the bolts to secure the mechanical disc brake assembly. Continuing to machine another small flange assembly, TIG welding the screws around the center circle. This will be the central mounting bracket for the front wheel. Installing the rim flange onto the shaft and dropping in the nuts. Tightening the bolts symmetrically to create a balance of force. This whole assembly is attached to the second axle tube. Using a wrench to lock the cylindrical bearing bracket. Every detail must withstand bending and torsional loads. Another brake disc is installed for the front axle system, inserting this axle assembly into the core of the giant steel disc. The highly unusual dual hub system is now complete. Now it's time to attach it to the truck tire rim. Lifting the incredibly heavy hub block and fitting it into the wheel rim. More than a dozen bolts perfectly pass through the aligned holes. Gently rotating the brake disc to check the smooth rotation of the bearings. Tightening the nuts by hand, the threaded joints mesh smoothly. This process requires immense patience. Tightened with a wrench, the truck wheel has now become a motorcycle wheel. Both front and rear wheels are successfully fitted with hubs. The mechanic searches for a pair of shock absorbers in the scrap pile. A pair of long-travel red coil shocks catches his eye. Remove the buffer pin at the top of the fork to prepare for modification. Take a thick steel billet and measure it with a tape measure. Use a marker to sketch diagonal lines for a diamond shape. The angle grinder cuts through the steel block, sparks flying, creating a load-bearing diamond-shaped flange for the front fork. The excess billet falls off, grind and round the cut edges. Place 2 cylindrical steel tubes at both ends of the billet. Position with a tri-square and fine-tune with a hammer. Tack weld to temporarily secure the connecting angles. The V-shaped front suspension fork is gradually taking shape. The mechanical structure ensures effective vibration damping. The welding torch continuously makes basic passes. Weld the cross brace securely to the 2 fork pillars. The U-shaped bearing pillow block is also disassembled. The mechanic prepares a thick, square steel base. Insert 4 bolts through the positioning holes on the steel surface. I place the pillow block on top, insert washers, and tighten the nuts. Use a wrench to lock the steering stem bearing block tightly. The central steering shaft will rotate on this bearing. Measure to find the center point of the V-shaped fork. Mark with a marker to determine the steering center. Tack weld the steering shaft to the triple tree, along with angle brackets, enhancing the bending strength of the steering system. Move on to process the coil spring shock absorber casing. A steel bushing is welded with an additional nut clamp. The TIG arc melts and bonds the clamp. Insert this bushing into the lower end of the red shock absorber. Tighten the nut to clamp the shock absorber securely to the wheel axle. Insert the 2 fork legs into both sides of the giant hub. Install the upper triple tree onto the top of the 2 fork tubes. Tighten the locking nut connecting the frame and the wheel. The front wheel can now stand firmly and steer. But for safety, a horizontal axle pinhole needs to be drilled. The drill bit pierces through the fork casing and the steel core axle. Insert a cotter pin and bend the ends to lock it completely. Now proceed to weld the main chassis of the vehicle. Use rectangular steel tubing to assemble a square frame. TIG weld the V-shaped angles of the rear swing arm frame. The deep weld penetration ensures the frame won't tear. The shape of the rear swing arm is gradually emerging. The mechanic continues to take a flat steel bar to measure and cut. The metal hole saw in the drill press is working, creating a perfectly round hole on the thick steel billet. Use an angle grinder to cut and expand the hole's diameter, forming a U-shaped slot to mount the rear wheel axle. Brilliant sparks fly as it cuts through the tough metal layer. Weld these U-shaped slots to the 2 ends of the rear swing arm. The fish scale weld bead running along the flange looks very beautiful. Continue using the grinder to smooth out the protruding welds. Join the front and rear frames with a heavy-duty door hinge. This is a highly unusual articulated steering mechanism. Weld the steel hinge securely to the load-bearing box frame. The vehicle will operate with an articulated body mechanism. The soul of the monster appears, an old motorcycle engine. A 110cc engine block from a dilapidated bike is salvaged. Place the engine on a flat surface and proceed with cleaning. Use a brush and a compressed air nozzle to blow away the rust. The air nozzle blows away the dirt, lodged deep inside the cooling fins. The engine block surface is shiny again after cleaning. Measure the positions of the engine mounting holes. Transfer the dimensions onto a flat surface, a solid steel plate. A marker draws intersecting lines to determine the hole centers. The steel drill bit creates a solid mounting base for the engine. Spiral iron shavings pop out as the machine continues to drill holes. The positioning holes are ready to embrace the engine block. Attach the steel mounting base plate to the side of the engine block. Use a wrench to tighten the hex bolts, passing through the engine block. The mounting base, firmly attached to the engine, is placed inside the frame. Position the fulcrum point so that the drive chain is as straight as possible. Install the gear shifter and kickstarter to align the tilt angle. The TIG torch secures the contact points between the base and the frame. Weld the foot pegs in place and reinforce the lower base joints. The enclosing box structure ensures the engine does not vibrate. A vertical pillar frame is erected, along with a coil shock system. This is the central shock absorber for the rider's seat. Fabricate the seat support bar from a long rectangular steel tube. Weld flanges on both ends. Use a grinder to smooth the beveled edges. Place the support bar into the vertical frame. Align for perfect balance. Tack weld securely to create a subframe to support the seat. The deep welds withstand the direct compressive force from the rider. All details of the central chassis have been etched into a solid block. Elevate the frame and back the giant rear wheel into position. The U-shaped rear swing arm slides straight into the truck wheel hub. A locking clamp bar is inserted to secure the horizontal axle. Assemble the dual coil shock unit to dampen the drivetrain. Tighten the nuts at both ends of the multi-suspension system. The heavy rear wheel is safely connected to the chassis. The front fork shaft is threaded through the steering neck bearing. The frame connecting the front wheel and the body hinges in the middle, securely welding the entire steering neck and fuel tank mount. The massive weight now takes the shape of a hybrid motorcycle. The mechanic jumps onto the saddle to test the bounce of the suspension, installing the brake caliper onto the front V-shaped bracket, welding the brake caliper bracket permanently to the frame, ensuring maximum braking power, attaching the small drive sprocket to the engine's output shaft, locking the sprocket securely with a snap ring. There's a large size difference between the front and rear sprockets. A thick motorcycle drive chain is threaded through the system, locking the chain with needle nose pliers. Because the swing arm is too long, the chain is slack. The mechanic fabricates a chain tensioner roller assembly, using 3 small bearings joined and welded onto a steel base, attaching a long threaded bolt, flexibly adjusting the chain tension, mounting the tensioner to the swing arm, pushing the roller to press tightly against the chain, tightening the lock nut. The chain tension is now ideal, forming an aggressive and unique mechanical machine. Installing the handlebars, hydraulic brake lever, and ignition switch. Using a T-handle wrench to tighten the electrical switchgear. Continuing to tighten the screws to secure the aggressive rear-view mirrors. The control cables are neatly bundled along the handlebars. The mechanic begins connecting the main wiring harness, routing the throttle cable and hooking it into the carburetor's throttle slide. The spark plug boot is plugged tightly into the cylinder head. The electrical connectors are hooked up to the battery's positive and negative terminals, returning to the handlebars to fine-tune the mirror angles. Installing the brake line fitting into the hydraulic brake lever assembly. Tightening the banjo bolt to ensure the system is sealed. Using a screwdriver to open the brake fluid reservoir cap, preparing to pour in the fluid. The other end of the brake line is routed down to the brake caliper. Attaching the fluid bolt into the copper-colored Nissan brake caliper. Wearing gloves and carefully bleeding air from the hydraulic system. Pouring specialized brake fluid to fill the reservoir on the handlebars. The pale yellow liquid fills the pressure chamber. Checking for air bubbles, then covering it with the rubber diaphragm and reservoir cap. Tightening the screws to secure the fluid cap, sealing the system. Lifting the bright yellow teardrop fuel tank and placing it on the frame. Positioned right on the main frame, exactly next to the leather seat cushion. Plugging the white fuel line into the petcock assembly. Connecting it straight down to the carburetor's intake port. A blue chain guard panel is installed. Using a drill to drive screws directly into the rear swing arm frame. The The final step is attaching the exhaust pipe header to the engine block. The shiny chrome-plated exhaust pipe is securely tightened with nuts, tightening the shiny metal-rimmed gas cap. All assembly steps have been excellently completed. The engineer lifts his leg and climbs onto the uniquely designed saddle, inserting the key into the ignition and turning on the electrical system. Kicking the starter lever, the 110cc engine roars smoothly to life. The mechanic twists the throttle, accelerating the monster machine onto the road. The massive weight moves smoothly on the asphalt road, a perfect combination of a custom hub and truck tires, passing by stretches of green trees. The vehicle rolls forward powerfully. A masterpiece of unimaginable mechanics stands as a testament to creativity.